So আমরা এখন যে প্রবলেমটা দেখব, this problem is known as inversion count. Okay, so let's see what this problem means. এখানে বলছে you have given an array which is size of n and you have to complete the following tasks. First taskটা হচ্ছে you have to count the number of inversions, and second taskটা হচ্ছে sort the array in non-decreasing order. So আমরা basically first taskটা দেখবো যে how to do the inversion. ওকে, সো ইনভার্সন হওয়ার জন্য এখানে একটা কনস্ট্রেইন্ট দেয়া আছে। So let's say we have a pair of elements I and j, এর i ইন্ডেক্স যদি j ইন্ডেক্সের চেয়ে ছোট হয় and i ইন্ডেক্সের যেই ভ্যালুটা আছে ওইটা যদি j এর থেকে বড় হয়, রাইট? সো अगेन i ইন্ডেক্স যদি j ইন্ডেক্সের থেকে ছোট হয় and i ইন্ডেক্সের যে ভ্যালুটা আছে ওইটা যদি j ইন্ডেক্সের ভ্যালুর থেকে বড় হয়, in that case we'll consider that pair as a inversion pair. তো আমরা এইটাকে যদি একটু নিচের এক্সাম্পলটা দিয়ে দেখতে চাই, সো লেটস সে আমার কাছে হচ্ছে ফার্স্ট পয়েন্টারটা এখানে which is I and j should be greater than I, right, to satisfy this constraint. এখন আমার i তে যে ভ্যালুটা আছে which is 5 and j তে যে ভ্যালুটা আছে which is 4, so a of I is greater than a of j, so we'll consider it as a pair. So our count is equals to 1. If we move forward, then we'll see 3 is also greater than 5, 2 is also greater than 5, and 1 is also greater than 5. So we'll have 1 plus 1, 1 plus 1. Okay, so now let's move forward. We will move these pointers here and do the similar calculation. And in this case, we'll get 3 is greater than, 4 is greater than 3, 4 is also greater than 2, and 4 is also greater than 1. So we will again get 3. 1 plus 1 plus 1. Now if we move our pointer slightly further, then we'll get again two pairs, which is 3 and 2 and 3 and 1. So we'll simply add 1 plus 1. And lastly, we will have another pair, so these two, and we'll get another one. So let's count. A lot of ones are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Yeah, that's our inversion count. Now let's see how can we solve this problem. So the naive approach should be we can maintain a loop for I. For I we can run a loop, and for each I we'll run a loop j which will be starting from I plus 1 to len of our array, right? So this is basically the naive approach. What's the time complexity here? It's almost order of n square. Not exactly, because we are not iterating through all the n. There is always one number shorter for each of the I. Okay, it's approximately order of n square. Well, so what our agenda is, we always try to minimize the exponential complexity. We'll simply divide this array into two halves. So the total element of this array, or if we calculate is if we consider the middle element like this, mid equals to left plus right divided by 2, where left is 0 plus right is 0, 1, 2, 4. So we'll ended up with getting 2, which is this part. So one part will contain 5, 4 and 3, and the other part will contain 2 and 1, right? Okay, so now our problem is to merge this thing and count the number of inversions. So we successfully converted our given problem into a divide and conquer approach, and when we are basically merging these two arrays, we'll get our answer. Now let's see how we will exactly get our answer. For that, let's for now assume all the arrays of this level are sorted. What it means is, let's write here, let's the left part of the array should be look like 1, 4 and 5, and the right part of the array should look like 1 and 2. Okay, so given that you have to sorted array, you have this one and this one sorted array, you need to find you need to find the count of inversion. Okay, so let's see how we can solve that. Initially our count, let's say 0, and we will use 2 pointers, and we saw a similar approach while we doing the merge operation in the merge sort. However, I think I made a mistake here. This is not 1, this is 3. Okay, so yeah, all right. So now we have I pointer here and j pointer here. So we can say, while we're merging these two things, the value of j pointer, which is 1, will be add to the starting of this array. Alright, and then we will, what we did in merge sort is simply move this pointer to the right. Alright, so we'll do or perform some calculation while calculating this merging operation. How? Let's see this. Let's see this. So yeah, our I is here, which is at the leftmost part, and our j is here, which is at the rightmost part. So can we say our I is less than equals to j? We can say, right? কারণ আমাদের I হচ্ছে এখানে and j হচ্ছে front of I, right? So our I is less than equals to j. So now can we say the value of I, which is 3, is greater than the value of j, which is 1? Yes, we can say 3 is greater than 1, right? So what we simply did is we just simply satisfied these conditions, these two conditions, and therefore our count is basically 1, right? Okay, now here, if you notice, if this condition satisfies, which means 1 is greater than 3, then all the element right to the 3 এর ডান পাশে যত এলিমেন্ট আছে সবার জন্যই এই কন্ডিশনটা স্যাটিসফাই করবে, which means what I'm trying to say is 4 is also greater than 1 and 5 is also greater than 1. So let's move this two thing to the right so that I get some space. Right. So now we can see we have three things, three pairs. We get three pairs. This one, and this one. Right. So instead of 1, we simply add 3. Alright. So let's continue the same thing. We simply merge this one to our new array and we move it to further. Now let's see, is I less than j? Yes, it is. Yes, it is. Value of I is greater than value of j? Yes, it is. So we got a pair, and this 4 is also greater than 2 and this 5 is also greater than 2. Therefore, we get 3 more pair, which is plus 3, right? Now what do we do? আমরা just simply এখানে 2টা বসাই দেব, and then we will move our j to further. So if we move our j to further, we do not have any other thing left, so we'll simply just append these numbers in the front of my list, which is 4 and 5. So here the total number of inversion count is 6. So let's see if it's correct or not. Let's say we have an array like 3, 4, 5, 1 and 2. What's the inversion count? So we can see 3 and 4 is an inversion. No, this is not an inversion. So 3 and 4 is not an inversion. 3 and 5 is not an inversion, but 3 and 1 is an inversion, right? So our inversion count is 1 plus 3 and 2 is another inversion. So we'll get another one. Now for 4 and 5 is not an inversion, but 4 and 1 is an inversion. 4 and 2 is an inversion. And similarly for 5, should be 1. For 5 and 1 is an inversion. 5 and 2 is an inversion. But for 1 and 2 is not an inversion. So total number of inversion is 1, 2, 3, 4, 5 and 6. 6. So that's how we can calculate the inversion of an array if it is sorted, or if the two halves of an array are sorted. So how we can get these two halves of an array which is sorted in nature? For that, we will revisit the concept of merge sort. So in merge sort, what happen is, let's say we have an array like 1, 2, 5, 4, 3, 2 and 1, and we divide it like this: 5, 4 and 3, 2 and 1. The next step, we'll divide it like 5 and 4 and 3, and here we will get 2 and 1. If we divide it again, we'll get 5 and 4. Now we have array with length of 1, right? And can we say, if a array has one element, then is it sorted? or not? It's obviously sorted because one element is always sorted in the array. So if we implement this recursive relationship similar to merge sort, we will get 4 and 5. We'll get 4 and 5 in the next step, right? Similarly, here and here we'll get 3, 4 and 5, right? For this part also we will get 1 and 2, and then here we will get this two part of the tree. So now let's see the left part. This is the left part of the tree, and this is the right part of the tree. Similarly, back to the previous approach যেটা আমরা একটু আগে দেখলাম, ওইটা দিয়ে তো আমরা হচ্ছে এটাকে সলভ করতে পারবো, right? Because now we have to sorted subarray. We simply want to merge them and we will get our count. So in each merge operation we will do the similar thing. So for here we will get a count of 1. Yeah, I is greater than j, so we'll get a count of 1. Similarly, for there we'll get maybe some count of some numbers, and if we add up all this count from each of the merging level, we'll get our entire count, which is 10. So that's it. Hope you guys understand the problem. Thank you for watching this video.